what you can gather from this rule is that if the bases are equal, the powers are equal. And we're going to use that the whole time today. Sometimes we're going to be rewriting equations to get common bases first, because then we can follow the rule. It's got to look like b to the whatever and b to the whatever. Okay, so hold on to that. Here's example 1. Example 1 says solve. All of our examples today say solve. That's it. We've got 2 to the x minus 1 equals 2 to the 2x minus 4. And so your first check here is, are your bases equal? Okay, and so if that's the case, then you're ready to move on to the next thing. You're going to set powers equal to one another. Set powers equal to each other. And then your step 3 is going to be solve for x. And it's really that simple, that straightforward. So if your bases are equal, then your powers are equal. So we have x minus 1 equal to 2x minus 4. And we're going to solve for x. I tend to go letters to the left, numbers to the right. I prefer that when I'm solving inequalities. It doesn't so much matter when I'm solving equations, but it's handy. So we've got x minus 2x, maybe negative x, equal to negative 3. And x is 3. Where did what? I added this one to this side, and I subtracted this 2x from this side. It was x minus 1 equals 2x minus 4. Okay. To check it, you would want to plug back in. So I would have 2 to the 3 minus 1. What's 3 minus 1? 2, so 2 squared. That would make a 4 on this side. 2 to the 2 times 3, that's 6. 6 minus 4, also 2, so 2 squared on this side, 4 is 4. We're good. That's your check. You're just trying to make sure you get the same thing on both sides. Questions at all here? Okay, I'm going to skip the try it because I think we're going to get enough of this that we don't have to do that one. Okay, here's example 2. Sometimes it's not so obvious, and you might have to rewrite with common bases to solve. Rewrite with common bases. So here we have 8 to the x plus 2 equal to 16 to the x plus 1. And I want you to resist the urge to divide by 8 or divide by 2 or whatever that thought might be. Okay, we want to think about common bases. So think a very small number that when I raise it to powers, I would get 8. When I raise it to a different power, I might get 16. 2. Okay, so if I were going to rewrite 8 with a base of 2, what's an equivalent statement? 2 to what equals 8? 3. So I could rewrite the 8 as this. 2 cubed to the x plus 2 is equal to, how could I rewrite 16 with a common base of 2? 2 to the 4th to the x plus 1. Are y'all following that? Okay. Look up here on this board, the laws of exponents. When I raise a power to another power, what do I do with my powers? Multiply them. So that's going to look like distribution here because we have a binomial and a monomial, and we're going to push that 3 through both. So it's going to be 2 to the 3x plus 6 equal to 2 to the 4x plus 4. Y'all see that move? Now I have the equal bases. I can set my powers equal to one another. And solve for x. You good? I got x is 2. I saved some heavy work for you. 8 to the 4th is equal to 16 to the 3rd. Both of them equal 4,096. Yes, I did that in the little office this morning. There was a man next to me wondering, like, what is happening? Stay cool, dude. I'm just doing exponents. It's fine. Any questions on this one? Yeah? I'm solving, so I move letters to the left and numbers to the right. So I could get x by itself. A lot of times we'll write that all out in a lot of steps, but I figure you've been solving for a while. Good question. On to the next. Cassandra, say when. Whenever you want us to move on, we can. You're good? Okay. I don't like that green color at all. All right, here's a try it. Let's do 5 to the 2x equals 25 to the 3x plus 2. And we're thinking common bases. So how could we rewrite the 25 in base 5? 5 squared. So we're going to have 5 to the 2x on the left and 5 squared to the 3x plus 2 on the right. And then we'll push that 2 through the binomial. It's going to multiply by both of those. So 5 to the 2x equals 5 to the 6x plus 4. Perfect. Now I have like bases or common bases. That means my powers can be equal. And I got x equals -1. If you plug that back up here, that makes 5 to the -2 equals 25 to the -1. That's 1/25 and also 1/25. Right? If I raise to a negative power, that makes a fraction. Any questions on that? Okay. Let's keep on zooming through here. This is example 3. Our problem says 2 to the 5x equals square root 2. So you don't have to change your base here, but you would rewrite the square root with a power. So the square root could become what power? 1/2. So you have 2 to the 5x equals 2 to the half power. Same base, powers are equal. So 5x equals half. Divide by 5 on both sides. I would send the 2 to the bottom with the 5 and call it 1/10. But if you're not in that habit, you could also multiply by the reciprocal, which would be 1/5. Also gives you 1/10. right? So I could throw that 5 over 1 and then multiply by the reciprocal, and I land at 1/10. I think it's easier if you have a stacked fraction to just send the bottom to the bottom, and that way everything's on the bottom. Cool beans? If I put the 1/10 up here for x, what's 5 times a 10th? Half. So you get the same thing on both sides. Good. Okay, here's example 4. I'm going to just stay on this same page. Example 4 says 3 to the x plus 1 equals negative 2. 3 to the x plus 1 equals negative 2. So one problem with this is I'm not going to find a common base between a base of 3 and a base of 2. It's not going to happen. The other problem with this is 3 is positive. What kind of picture would this be? If I were going to graph it, it would be exponential. Would it be exponential growth or exponential decay? Growth. Why? Because 3 is greater than 1. That was the rule. If my base is greater than 1, this thing's growing. Okay, so imagine that this 3 looks like this. This is the top function. And how does it go as x decreases? What's it going to do? Can't get below 0. Does it even touch 0? No, because once there ever was a piece of donut, then there always will be, right? You all remember that analogy? This has what we call what? On the line, y equals 0. Yeah, perfect. Horizontal asymptote. So let me ask you, will this function, as it rides out into the sunset, ever intersect with the line y equals negative 2? No. And that's why. Because it's above the x-axis. There is no power that I'm going to raise it to that makes it be negative. Not if the base was positive. Not even a negative power. A negative power would make it just be smaller, right? Those come out as fractions. So the answer here is no solution. But I thought it was worth discussing. I thought we need to wrap our minds around that. It's not that x will never be negative. It's not anything like that. It's that the exponential function itself will not be negative. Okay. All right, that is the end of the lesson. So I'm going to put your homework up here, and I'm going to pause the video and give you just a chance to write it down. Thank you. We're doing 4 through 10. So if you wanted to write a couple of these down right quick, I'll let you, and then we'll work some. Okay, number 4, you've got common bases. That's not a problem. You're just going to be able to set your exponents equal to one another and solve. Okay, I don't want to have to go through that with you. I think we've worked a bunch of examples where that's going to be easy. But if we look at number 5, what? That is not at all what we just did. Okay, so what we looked at were all of these that just had one little base, one little power, and nothing special about it. Number 5 doesn't look like that at all. Can you tell that the common base that we want to arrive at is 4? Okay, so if we rewrite 16 in base 4, what could we call that? 4 squared. So instead of 16, let's call it 4 squared. Keep the 4 to the 3x. But we're gonna call the 64 also something in base 4. What would you call that? Four cubed. 64 is 4 cubed. So we'll have 4 cubed times 4 to the 3x times 4 squared. Are you seeing what I'm saying? Okay. Now you have to use properties of exponents. Look up here at the little picture. When you multiply like bases, what do you do with the powers? Add the powers. So this is actually going to be 4 to the 3 plus 3x equal to 4 squared. Now we've done it. Now we have common bases, and we're able to set our exponents equal to one another. Could you solve it from here? X equals, no, negative 1/3 is what I got. 3 plus 3x equals 2. I got x equals negative 1/3. Is that helpful? Okay. You could do the same thing with number 8. That one's not going to be too bad for you. Let's hop over here to number 6. We have 3 to the 2x plus 1 times 3 to the x equals 243. A common base for 243. What do you think? 3 to something, right? 3 to the 4th is 81. That's a pair of 9s. Okay, always remember that. So 3, 9, 27, 81. But I get to the 81 because I had 9 times 9. You following that? Go one more. 3 times 3 again. That's your 243. So it's 3 to the 5th. And again, on the right side or on the left side, when I multiply like bases, what do I do with my powers? Add them. So you're going to have a 2x plus 1 plus another x. 3x plus 1. 3 to the 3x plus 1 equals 3 to the 5th. Then you're ready to go with it. You ready to look at 7? You see this 1/4? You see how gross that is? Could you look at it as 1 over 2 squared? 1 over 2 squared. Does that help a little? But then we need that base in the top. I don't need it to be 1 over 2 squared in the bottom. I need the 2 to be the base in the top, like all the other 2's. So how do I get that 2 out of the bottom? Make the exponent negative. Okay, you got to make it unhappy in order to get the 2 where you want it. Right now it's 1 over 2 squared in the denominator. You want it to be 2 to the something in the top. Do you understand what I'm saying, Gracie? Yeah? So this now becomes 2 to the negative 2 equal to 2 to the n plus 2 and times 2 to the negative 3n. And again, when you multiply those bases, you get to add your powers. I wouldn't write negative 3n plus negative 2. In Big Kid Land, it's fine to just say negative 3n minus 2. We're combining. Do y'all have time to look at number 9 before we get out of here? I think we have time. We have like 15 minutes left. Ashley, what's the rule if you're dividing like bases? You subtract your exponents. So we have 36 divided by 36. Those are the same base. So we can subtract 3b minus 2b. 1b. So we have 36 to the b power equal to 216 to the 2 minus b. Anybody want to take a guess at what base we're targeting here? 6. We're looking for base 6. So 36 is base what? In base 6 is going to be 6 squared. 6 squared to the b power. 216 in base 6 is 6 cubed. 6 cubed. 6 cubed to the 2 minus b. So now you're going to distribute your 2, and it's going to be 2b, or not 2b, is equal to 3 times 2 times 3 times negative b. I've got 6 minus 3b. Did you get an answer, Tate? Is it a weird fraction? Me too.
6/5.
Yeah. 6/5. Confidence, young grasshopper. And I stopped y'all on number 10 on this particular assignment. So we're just doing 4 through 10. That was number 9. We'll look at 10, and I'll get you going on it, and then I think you can finish in this class period. Is that good? Don't forget that you have 6-5 homework due tomorrow. That was the logarithmic expansion and condensing. Those were easy. First, number 10. There he is. Okay, number 10. What base are we trying to go to here? Base 2? So let's rewrite the 8 in base 2. What you got? 2 cubed. 2 cubed for the 8. 2 to the 6th can stay 2 to the 6th. But how about that 1 over 64? Okay, 64 is 2 to the 6th power. I always see my hand when I see a 32, I think 2 to the 5th. And then one more would be 2 to the 6th. You following that? So 2 to the 6th is 64, but it's 1 over 64. So to handle the fact that that's a fraction, we do 2 to the negative 6. And then we'll raise it to the 3n power. This color is terrible. I'm going to rewrite all of this in not green. I don't know why I picked green again. Okay, so we have 2 to the 6th. We have 2 cubed here. We have 2 to the negative 6 to the 3n power. So we're going to first raise a power to a power. Okay, so that's going to come out as 2 to the negative 18 n times 2 cubed equals 2 to the 6th. Now when I multiply like bases on the bottom, what do I do with my powers? Add them. So we have 2 to the negative 18 plus 3 equal to 2 to the 6th. And I think you can see now you can set your exponents equal to one another and solve. Cool beans? Any questions on that at all? All right, so that should finish up your homework. For 10, I got negative 1/6. I lost my n. Yeah. Yep.
What did you get for number 6?
Number 6, I got 4/3.